We begin by separable differential equations. So a differential equation is an equation, has an equal sign, that has a derivative in it. And we're going to separate the variables. So let me explain what that means with this first example. So here I have y prime equal e to the 2x divided by 4y cubed. So first step is rewrite y prime as dy over dx. Okay, so let's make sure we're really clear on that. Y prime is dy over dx because it's the derivative with respect to x of y. Okay, so once we do that, then we work on getting y's on one side of the equation, x is on the other side. That's why we call it separating variables. So I multiplied by 4y cubed, multiplied by dx. Always keep the dx and the dy in the numerator, right? Always keep the dx and the dy in the numerator. Okay, so once I have that, it's looking like it. Can you see it? It's calling for it. It just needs integral signs so that we can integrate. So we integrate both sides. And I recognize this as y to the fourth, so the 4's cancel, so I get y to the fourth, plus a constant on the left-hand side. This is my little La Jolla theorem. Make it a 1/2 e to the x, e to the 2x, plus a constant on this side. So I want to put the constants on one side. So let's move them over to the right-hand side and make it e minus d, and I'll call it c. All right, so we can do this. We can always just put 1c on one side of the equation. We're always going to choose the side with x's. So make sure you put the c down right after you integrate. Then finish solving for y. So put this, now solve for y by taking the fourth root of both sides, so plus or minus the fourth root. So notice it's a fourth root, it's a plus or minus because it's a fourth root, right? Just like square root. And this plus c had to have been placed right after you took the antiderivative. So if you had waited and taken the fourth root of this 1/2 e to the 2x and then put the plus c on the end, that would be incorrect. So you must put the plus c right after you integrate. So the c is going to be nested inside. All right. So you always have dy and dx in the numerator, right? Always multiplying by dx to get it in the numerator. Okay, so it'll just say solve. So what am I solving? Let's just go back a second. So what I'm solving is the function that will satisfy this equation. So if I take the derivative of this y, it equals e to the 2x over 4y cubed. Okay. So, and there's a constant there because there's going to be a family of solutions. All right, let's solve this one. So 2 times y prime equal xy over ln of y. Okay, first step is always rewrite y prime as dy over dx. Don't get that mixed up because that will get you in big trouble. So dy over dx. Then you're going to multiply by dx and then multiply by ln of y. So now keep the dx and the dy in the numerator. Then I integrate both sides. And each one is going to be its own fun adventure. So on this left-hand side, I can see easy u substitution. Let u equal ln of x. Ln of y, right? And then du is 1 over y dy. So then I put that in, so I get u du, and I can just easily integrate that. So again, as soon as I take the antiderivative of this right-hand side, I'm putting a plus c. So when I take the antiderivative here, I get u squared over the 2, but it cancels with this 2. So there is a c, but I just am joining it together in this c. Put the y's back in. So I get ln of y squared equal x squared over 2 plus c. So now I need to do algebra to solve for the y. So first, I'm going to take this, take the square root of both sides. So that means I get a plus or minus. And that plus c is inside the radical. And then I'm going to take the e of both sides. So e to the ln goes away. So I just get y. So this is all in the exponent of the e. All right, looking at this one. Starts off not looking so familiar because what was the first step I did in the separable? I cross multiplied. I can't cross multiply when it's written like this. All right, so first step is to get this e term on the right hand side. The second really important step is to separate. So e to the t plus y is the same thing as e to the t times e to the y, because you know you add exponents when you multiply things at the same base. All right, so let's multiply both sides by dt and divide by e to the y. All right, so I'm ready to integrate, right? Calling for integral signs. And then remember, this 1 over e to the y can be rewritten as e to the negative y. We want to do that because then we see this is an easy La Jolla theorem, right? So this is the a is just a negative 1. So I get 1 over negative 1, e to the negative y. Antiderivative here is just e to the t, 1c. 1c right here, don't forget it. You must do it right after you do the antiderivative and put it on the side that doesn't have the y. I'd say x's, but this one has t's, correct? All right, so then I'm ready to multiply through by negative. And you don't need to multiply the c by a negative. You could have just said, you could have kept it as c, or we could change it to d. It's up to you. It doesn't matter. It would be fine just to leave it as c. And then now I'm going to take the take the ln of both sides to undo the e, right? So you cannot take the ln of each one separately. So what would be wrong is to say this. Let me just write this down. Is to say, well, there's e to the t plus d. Sorry, that's kind of messy. Okay, so take ln is to say, oh, I'm going to take the ln of this term, and I'm going to take the ln of this term. You can't just go and take the ln of each term like that. Really bad math. So you take the ln of each side, the ln of this quantity, so that's all inside the ln, and then finally multiply by the negative. Again, you could have left it as c and just thought it just made it. It didn't matter. It doesn't matter.